Hello and welcome to helpyourmath.com. In this video we're going to look at the graphs of transformed sine and cosine functions. In this video we're going to look at 4 examples where there are no vertical or horizontal transformations. So first we want to determine the amplitude and period for each of the following functions. Then we'll sketch a graph of 2 periods of the functions. You can decide which 2 periods. I would probably start with whichever one you record the 5 key points for, but that's just me. All right, so first we want to determine the amplitude. Remember what the amplitude is? It determines the vertical height from the middle to the top, or the vertical height from the middle to the bottom. The amplitude is found by taking the absolute value of A, which in this case is 3, so this is A. And we can, oh, that looks like a 9. And that's B. Okay, B. So we would say the absolute value of 3, so the amplitude is 3. The period here, we determine the period by dividing 2 pi by B. So it's not as straightforward as the amplitude. So the period is going to be 2 pi divided by 2, which is pi. So what is a period? That is one complete cycle of the sine graph. So we're talking about a sine graph. Sine graphs start at the midline. They go up to the top, back to the midline, down to the bottom, back to the midline. So that would be one complete cycle. That's what it would look like. We're going to do 2 of those, then we'll just repeat that either to the left or to the right. To find the 5 key points for one period, since there are no vertical or horizontal transformations, the first one we always want to know is that sine of 0 is 0 itself. So we can fill in 0, 0. The next thing we want to do is determine the next 4 key points. And what we're going to do to determine the x intervals is we're going to take the period and we're going to divide it by 4. So we're going to do pi divided by 4, and this is going to tell us the increment that we want to use. So we're going to keep adding pi over 4 to determine the x coordinates for each key point in the first period. So we have 0, 0 plus pi over 4 is pi over 4. Then 0 plus pi over 4 plus pi over 4 is pi over 2, because it'd be 2 pi over 4. Then pi over 4 plus pi over 2 is 3 pi over 4. And 3 pi over 4 plus pi over 4 is pi. So this last one, assuming there's no horizontal transformation, should match the period itself, right? If we start at 0 and we're doing a complete period, then that's going to take us to pi. Filling in the y's. So for the y's, normally what a sine graph does is it goes from 0 to 1 to 0 to negative 1 to 0, but we have to take the amplitude into account. So instead of going to 1, at pi over 4, it's going to jump up to the amplitude and it's going to go to 3. At pi over 2, it goes back to 0. 3 pi over 4 will go down to negative 3, and back to pi will be back at 0. So another check is that the first y and the last y of any cycle or any period should match. Those should absolutely match. Now, we do want to label our graph. It's really important we do this so that your instructor knows you know what the increments on the x-axis are. Since my graph is a little bit thin, I'm going to actually do every other one. So I'm going to start here and call this pi over 4. And I'm basing my increments off the x values that I have. So then this would be pi over 2. I'm skipping this one. 3 pi over 2, 3 pi over 4, pi. And now I have the choice. I can keep going to the right, or I can go over here and just repeat what I had, but negative. So negative pi over 4, skipping 1, negative pi over 2, negative 3 pi over 4, and negative pi. It's really up to you what you want to do. The start of the period at negative pi, right, so that's the beginning of one period, that's going to go from negative pi to 0, would have the same y units as the period that we listed. So I could start at 0. Here I would go up to 3. I go back to 0. I go down to negative 3, back to 0. So that point 0, 0 ends the period that started at negative pi and also starts the period that starts at 0. So now I have 0, 0. Pi over 4, 3, pi over 2, 0, 3 pi over 4, negative 3, pi 0. And we connect these with a nice smooth curve, right? No sharp points here, not on our sine graph. And that would be 2 complete periods. Now I chose to go negative. You could also have just gone this way and gone up 3, back to 0, down to negative 3, back to 0 if you wanted to. That's totally fine. Okay, in our next example, this time we're looking at a cosine graph. So this is our a value, and the fact that a is negative indicates to us that, so normally a cosine graph will start at 0, 1, but this indicates it's going to start at 0, negative 1, or whatever the amplitude is going to affect that. So we're actually going to be starting in the negatives instead of the positives. This is a little bit tricky, so we want to figure out the value of b. Let's pull x out of the fraction, and then we could write this as 1/2 times x. So then we know that b is 1/2. The amplitude is the absolute value of a, so that's the absolute value of -2, which is 2, just indicating that the height from the midline to the top or to the bottom is 2 units. The period, we calculate the period by doing 2 pi divided by b. So this would be 2 pi divided by 1/2. Dividing by 1/2 is equivalent to multiplying by 2, so the period this time is 4 pi. For the 5 key points, again, what we want to do is we want to determine the increment. So what we're going to do is we're going to take the period and divide it by 4. This would be 4 pi divided by 4, which is pi. So we know this time we're using increments of pi's. We're going to start at 0. And remember, this one's a little bit tricky. So normally cosine is 0, 1. But because of the change in amplitude and the fact that the a is negative, indicates we're actually starting at -2. Then we're going to go pi units because we're going to add pi, and then it would go up to 0. We're going to add pi again. That's going to be 2 pi. We go up 2 units. Then we're going to add pi to our x. That gives us 3 pi. We go back to 0, and then we close out the x's at 4 pi. We're going to do our check. Does this match the period? Yes, it does, so we feel good about that. And 4 pi brings us back to -2, and again, these should match, which they do. So those are like 2 good checks that you can do to make sure you're on the right track. We're going to do 2 complete periods. This time I'll do 2 in quadrants 1 and 4. We're going to label this as pi. Remember, I'm skipping every other one. So this is 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, it looks like 511, 7 pi, and 8 pi. Starting down here at -2. And we'll put 2 up there. So -2, pi is 0, 2 pi is 2, 3 pi goes back to 0, and 4 pi goes back to the bottom at -2. Doing a second period, we would go back up to 0, up to 2, down to 0, down to -2. We connect these with a nice smooth curve. So this would be 2 periods of the graph of y equals -2 times cosine of x over 2. 2 more examples, and I'll go through these a little more quickly just because now we've seen 2, and you can go back and watch those if you need a little more explanation. The amplitude this time will be the absolute value of 1/4, which will be 1/4. And the period this time, so it should be 2 pi divided by b, will be 2 pi over pi, which is 2. Interesting, so we lost our radians. Or, well, not really, we lost our pi's, sad day. The key points, so this is a cosine graph. Cosine should start at 0, 1. We're going to use the amplitude to help us figure out that we're actually starting at 0, 1/4. If it's easier, you might just want to complete the x's first, just going across. That way you don't really have, you're just doing the same math. To figure out the rest of the increments, we're going to take the period and we're going to divide it by 4. That would be 2 divided by 4, so we're using half units. So next would be a half, then 1, 3 halves, and finally 2. And again, you can do the quick check there. All right, so we started a 4th, we go down to 0, we go down to our minimum, we go back to 0, and we go back to the top. Do the quick check to make sure that those match as well. When we go to set this up, we might want to be really careful here. So we know I like skipping just because my graphs are a little bit squishy. And we want to do 2 here. So I'll just keep extending this. This would be 5 halves. Then we have 3, 7 halves. And lastly, we have 4. I'm going to actually do this. 1, 2, 3. Here's where I'm going to put 1. 1, 2, 3, and here's where I'm going to put -1. That way I don't have to try to like do a really tight graph. I can just change the increments of y to make it so that my graph is a little bit easier to work with. So we're starting at 1/4, which would be right here, going down to 0, down to -1/4, back to 0, back up to 1/4, back down to 0, back down to -1/4, 0, ending at the top. Nice smooth curve to connect these points. And thus we have our cosine graph. In our last example here, we got some fractions here. The amplitude is going to be the absolute value of -2, which is 2. The period, so we're going to take x out of this. We're going to put it over here, and this is going to be our b value. will be 2 pi divided by 2 pi divided by 3. This would end up being, so actually these cancel and 3 moves up to the top, so our period is 3 this time. If you're not sure of that math, just remember we could rewrite this as 2 pi divided by 2 pi over 3. If you rewrite that as multiplication and put that over 1, you'll see the 2 pi's will cancel and the 3 will move up. The increments that we're going to use here is going to be the period divided by 4. So we're using increments of 3/4. Starting with the x, I'm going to say 0. We're going to add the increment 3/4. Add the increment, that's going to give us, that would be 6/4, which is 3 over 2. Add the increments, 6/4, that would be 9/4. And this better be 3/4 if I add the increments again. I hope it does work out. Oh, I'm sorry, not 3/4, that's the increment. It should be 3, right? Because it's going to be 12 over 4, which is 3. Okay, and then the period matches, which is good. Yay. Whoop. Okay, for the y, so this is a sine graph. Sine graphs start at 0, 0. This one doesn't have any horizontal or vertical transformations, so this one will also start at 0, 0. Then what's it doing? It's, okay, the amplitude is negative, so instead of normally a sine graph will go up, this one's going down to -2, back up to 0, up to its peak at 2, and back to 0. I'll make this one go negative as well, just because I've been ignoring the negatives over here. So we're going to do -3/4, -3/2, -9/4, and -3. Over here, we're going to have 3/4, 3/2, skipping 2, 9/4, and 3. And when we go to do this, we're going to start at the midline. We're going down because of the negative, back up to 0, up to 2, down to 0, down to -2, back to 0, back to 2, back to 0. And nice smooth curve here. And these have been some examples of graphing sine and cosine graphs.